Welcome back to GIS analysis at the University of Alaska, Fairbanks. In this session, I want to teach you how to use Arcmap efficiently and how to avoid some pitfalls I typically see with students that are just starting to use Arcmap. The first thing we'll do is we'll set some geoprocessing options. So if we go to the geoprocessing menu and then geoprocessing options, we want to have the ability to overwrite our output. So that will allow us, if we make a mistake, to use the same output name for any geoprocessing tool. So for example, if I click on overwrite, that will allow us to overwrite the output. We do not want background processing. A lot of times there's bugs associated with using geoprocessing tools and background processing. So let's not do background processing. And then the final thing is we want to add the results of any geoprocessing tool, add those new outputs as layers in our Arcmap document, and then OK. The second thing we don't want to do is output to our default geodatabase, because that tends to contain many different outputs. And you can imagine after 6 months, you'll have thousands of outputs in this default geodatabase. So we want to output to a more meaningful geodatabase that 6 months from now we know what's inside that geodatabase. So for example, we're going to output to this geodatabase named squares, and each square will be 10 wide by 10 long. So to specify that, if you go to File, Map Document Properties, and down towards the bottom, we'll specify our default geodatabase. So that's going to be our squares 10 by 10. And then down below our default geodatabase, we will check on store relative path names to data sources. And the reason why we do that is if we move this geodatabase from the C drive to a memory stick, it will still know where this geodatabase is located. And then also, I always recommend including your name and your email in this map document property, and then OK. So now what we have is we have our default geodatabase, and it's got this little home folder on it. So now what we can do is we can save our work, and we'll save it to an area we can remember, and let's call this startup. So now anytime we start Arcmap, all we have to do is open startup, and it remembers all our settings. So now if we go to our Arcmap geoprocessing options, overwrite is on, and background processing is disabled. And then we could go File, Save As, and then we could name this as, let's name it as squares. So now we have squares with all our settings from startup. So anytime we run a geoprocessing tool, it tells us when we fire it up, if we show help, it will tell us the purpose of that tool. And then each dialog that's required will have a green. So these are all required wherever there's a green dot. And then if we go inside a dialog, it explains what it wants in that dialog. So for example, this first dialog, it wants the name of the output feature class. So we could click on, and we'll go to our default geodatabase, and then we'll call this test square. And then we'll just do a test where our origin is at 0, 0, and then everything else we put in ones just as a test. And then OK to execute that geoprocessing tool. And we made a mistake. Our square is not straight north. So the beauty of geoprocessing options overwrite results, all we have to do is go to the result tab and double click and then we just change whatever we just made a mistake in. So our mistake was we want to go straight north, so the y-axis coordinate, the x will be 0. And then just OK, and that will re-execute that tool. And then we'll refresh our Arcmap display. So that's the nice thing about geoprocessing options. Overwrite, it allows us to fix mistakes very efficiently by just double clicking on the tool. And let's say we want our cell width to be 10 instead of 1, and our cell height to be 10 instead of 1. And then just OK. So now we have a new layer, and the layer, if we look at its properties, is now a height of 10 and a width of 10. Another problem I commonly see with students is they'll use a geoprocessing tool. For example, let's create a random raster, and we get this error message, tool not licensed. You don't have the necessary license to execute. There's no license available, and they panic. So don't panic. All we have to do is check on the license that we need for this tool. So here we need the Spatial Analyst license. So what you would do is go to Customize Extensions and turn on the Spatial Analyst license. And that gives you permission to use this tool. So then we can use this tool. The other tip is to use meaningful names. So for example, here our output, we name it random raster rather than getting into the habit of naming it raster 1, raster 2, raster 3, because 6 months from now you have no idea what raster 1, raster 2, or raster 3 represents. So try to use meaningful names in terms of output and in terms of field names. So here we're going to create a random raster, and it will be the same overall extent as our square, so 0 to 10. So there's our random raster. Okay, another example of a meaningful name is here we have our test squares. They're not polygons, they're polylines. So what we should do is name our field square line ID, and that would be a more meaningful name to remind us that these are the IDs from lines. And then we could calculate our lines to be object ID plus, for example, 100. So in this class, we typically work in geodatabase containers, but some students want to output to a folder, and one error they often make is when they output to a folder a table, they do not give it a .dbf for dbase extension. So for example, we could use copy rows, and we'll copy these 2 rows to a table. So I will output using copy rows, those selected rows, to a folder, and I will name the table selected lines with no extension. So then let's look what's inside that folder. So it gets copied into an info folder, which is a program from a company named Henko from the 1970s. And inside of that info folder, there's files that we have no clue what's inside these files. So let's get rid of this info folder, and this time we'll give it a .dbf extension. So the same name, but .dbf. So now inside our squares folder, we have more meaningful names, and this is actually the dbf table, and this is the metadata associated with the dbf table. So if we look at it, here's the metadata associated with this table. So likewise, if we have a raster and we put the raster, output it to a folder with no extension, it will be a cryptic 2-folder system. So for example, let's use copy raster, and we'll copy our random raster to a folder. So we're going to output to the same folder, and we'll name this raster random raster with no extension. So what happens is half of the raster information is put into this info folder, and then half of the raster information is put into this random raster folder. So and you have no idea what's inside these files, for example. So if you're going to output rasters to a folder, always output the raster with an extension .tif, and that will avoid that problem of no extension. It becomes an ArcInfo grid, which is sort of an ancient format. So here's our random raster.tif, and we could email it to a colleague. And here's the XML file that has all the metadata about this random raster.tif.